Hello everyone and welcome to a webinar on attacking the cloud with RedCloud OS. I am Nandini Bharadwaj, the operating officer at Cyber Warfare Labs, and I'm excited to have you all here with us today. So let's get started. So before we start, let me tell you a bit about us. Cyber Warfare Labs is a leading cybersecurity infosec company offering a comprehensive solution to help individuals and organizations to develop essential cybersecurity skills. So we have got three major platforms. That is, first one is Learning Management System platform, LMS platform. It provides you enroll user within course study materials, including HD videos and PDFs for a wide range of cybersecurity courses. The second one is CWL Cybersecurity Playground platform. So it offers in theme-based labs designed to simulate real-world scenarios. User can start the labs at their own convenience, providing flexible hands-on practice. And the third one is Infinity Learning Platform. It's a plug and play platform where it offers a immersive learning experience with the challenges across red teaming, blue teaming, and cloud security domain. It is currently free to enroll, so you can enroll anytime. CWL also offer customized on-site training requests and accept bulk orders for corporate training needs. So for more information or to place an inquiry, contact us at support@cyberwarfare.life. Okay, so let's move on to next slide. Okay, so our speaker of today's webinar is Abhijit Kumar. So Abhijit is a security researcher with an expertise in red team operation, network security, cloud infrastructure, and Linux system. He is also passionate about researching adversarial tactics, techniques, and procedure, and frequently experiments in his home lab. So we are excited to hear his insights for today, and this is all about the speaker. And as promised, we are excited to share that you will receive the coupon code for Multi Cloud Red Team Analyst, our best selling course, at the end of this webinar. So stay tuned for that. And the other promised materials like the video recording of this webinar and your attendance certificate, all the guaranteed items you will receive within 2 days on your registered email ID. So thank you for being part of this webinar and we look forward for your continuous participation. Okay, so from here, it's over to you, Abhijit.
Thank you. Am I audible? Can anyone confirm if the screen is visible?
Abhijit, as of now, your screen is not visible. Yeah, now it's visible.
Okay, folks. So first of all, let's start looking into what the cloud actually is, because this webinar is revolving around the cloud and how we can attack it. So cloud is just a server or just a system that is sitting on a provider's data center. You are just paying someone who is managing the infra, and they are giving you access for a limited period of time or whatever your uh, constraints are. So apart from this, cloud is very handy because we can manage the resources very easily and we get access to a lot of things. So which, if we want to deploy in our on-premises system, it could be hectic. We have to manage lots of networking, lots of configurations, lots of stuff, hardware, electricity, backups, and everything. And not to mention internet, which in my experience is often finicky. So this is the cloud, and these are some of the common services which are available with the cloud. So we can use cloud where we are simply getting the bare metal infra and we're building on top of it, and we simply call it infrastructure as a service. Then we get something where we are building something on top of it. So let's say we want to deploy a website. So one case is we can go with the infrastructure as a service where we have to provision the VMs, where we have to manage the networking, configure security rules, and whatnot. However, we can also go for this managed option where the provider will be managing the infra, and we are just simply deploying on top of it. And so let's piggybacking to IaaS. So in IaaS, we have to manage the infra as well. In PaaS, provider will be managing the infra. We will be deploying the service on top of it, and just everything on the level of the service and above will be our burden. Then comes the software as a service. So software as a service is where we are just simply getting access to a particular software which is running on God knows where. So just to give an example, we can consider AWS's cloud or Azure cloud as a infrastructure as a service. For the platform as a service, we can consider AWS Lightshell, which is a platform where we have to deploy where we have to simply deploy our website on one of the VMs that is managed by AWS. And software as a service, you can consider it as if you're using Gmail, or if you're using Google Workspace. So that comes under the software as a service. Now, let's see how we can access these particular AWS's or Azure or GCP's resources. So first and foremost is, so we simply have to use our browser, and they have their own login portals, like in AWS it is console.aws.amazon.com, in Azure it's portal.azure.com, and in GCP it's console.cloud.google.com. So these are some of the web portals through which we can access these particular cloud services. Then comes the term of CLIs. So, I mean, using these web-based portals is very good, very efficient. But some of the things we cannot do with these AWS, sorry, in these console-based or web-based access. So for those purposes, we have the CLIs. So these CLIs are developed by the providers themselves, and we simply have to download it, configure it with some of the identity credentials, which we will be looking in a bit, and then we can simply interact with the services with the CLI. So one of the advantages of this CLI over the traditional web-based approaches, in web-based systems, there are multiple things we cannot access or modify. Like some of the things, some of the restraints are there which we cannot do through the browser. So we have to do it programmatically through the CLIs or SDKs, which we will be looking in a bit. And then comes the third way which through which we can access the cloud services, and this is software development kits, SDKs. And these SDKs are also developed by the cloud providers. They are available in multiple languages, and one of the advantages of using these SDKs is we can write a script to automate some of the things. We can write some scripts wrapping around these SDK to build some custom infrastructure, or I don't know, testing some security or writing some tools around it. So if you look into some of the tools like Paku or whatever tools are there, so most of these tools, they are actually creating a wrap around the official SDKs, and they are building on top of these SDKs to build their tools. And even most of the tools, so they also do this kind of thing. Like if you are talking about the infrastructure as a code, so Terraform, it also uses similar approach. It uses the APIs. Also, these tools also they use the APIs of the cloud provider. So uh, they call the API, they perform the action, and they give us the response of whatever happened. Now let's look into how or with which credentials we can access these cloud services. So first is obviously the username and password approach, through which we can simply write our username in the text box, write a password in the text box, and click login, and we will be logged in. If we do not have MFA configured, that is, then we have, if we have to write the MFA and do everything. Anyways, so this is one of the very basic credentials which we get, and this is also how most people actually interact with the cloud services. Like they simply use the username password combination, log into the console, and have it. It also has some advantages, like you get some cookies that is stored, so you do not have, like if you are using a single browser without any tab isolation, so it will be easy. And if you also, there is another thing of risk here, because if you are running multiple tabs and you are not using any browser isolation, so a potentially malicious website can actually extract those cookies and use it to interact with these services pretending as you. So this is something to keep in mind. But anyways, moving forward to the second type of credentials, these are the access credentials. So These credentials are what which is used with the CLIs and SDKs, and these credentials come in various forms. So first is the keys. These keys are access keys, which can be either the long term or short term, which we will be looking in a bit of time. So apart from these keys, we also get some tokens. So these tokens are actually generated. Usually these tokens are generated when we are using the keys to interact. So when we use these keys to authenticate with the CLIs or SDK, so they actually interact with the API of the cloud provider. And after the authentication and authorization, the cloud provider sends back some tokens. And these tokens have a particular scope, which in and consider the scope as something like a boundary, permission boundary, which is the maximum boundary this token can access maximum number of things. So let's say if I have a credential, I am keys I have generated for AWS, and let's say I have a scope this key so that it can only access one particular EC2 instance. So the token I'll be receiving from the cloud provider, it will be scoped to that particular EC2 instance. So I cannot access anything outside of that. So these are the things of these. This is how token work, and then there comes the concept of service account, which is mostly popular in GCP. I mean, GCP uses these service accounts to interact with, not interact, but to manage the services we provision. So let's say if we are creating a compute instance, so GCP will also create a service account, and it will link that service account to that particular instance. So in such a way that this service account has the power to perform certain operations on a particular resource. This is how the concept of service account works. And then comes the federated identities or single sign-on. So these are actually very useful when we are dealing with lots of accounts, lots of services. So let's take a real case study. So let's say we are talking about an organization with I don't know, thousand of users, and these thousands of users, let's say they have access to multiple cloud accounts. They need access to multiple cloud accounts. Now, if even if we have 1,000 user, and even if one is getting access to a single cloud or three of the clouds or four of the clouds, so the number of credentials will be increasing exponentially based on how many credentials are required. So to solve this issue, the federated identities or single sign-ons, they come into play. So through this, we actually configure these cloud services in such a way that we only need one type of credential to log in and to one particular identity provider, and from that provider we can access multiple cloud services. So this is how the concept of SSOs work. And coming on to the RedCloud OS, so RedCloud OS is something we actually developed last year, and it is a Debian-based operating system which we specifically created to solve the issue of having a particular OS specifically targeted for performing cloud operations, cloud assessments. And before this, I mean, we have tools, but uh, collecting all the tools in one place and having them ready for a particular assessment, it is a big task. I mean, we can automate it, but uh, even automating it is pretty hectic. So we went ahead and we created this Red Cloud OS. It is open source. It is available on our GitHub, and we'll share the link in a bit. So with this RedCloud OS, we can use or we can access or we can access multiple cloud service providers. I mean, be it AWS, Azure, GCP, even some of the other clouds like Oracle or IBM Cloud. We can also access those clouds using these using the tools that are present in the RedCloud OS. So in RedCloud OS, as of now, we have 52 or 53 tools, which are some of the tools are specifically targeted for AWS, Azure, and GCP, and some of the tools they are available for performing multi-cloud assessments. And this RedCloud OS is available for x64 architecture. As of now, we officially recommend you use VMware Workstation. It is free now for personal use. And we also recommend you, if possible, try to um, not use Windows 11. I mean, there has been some issues in the past. I mean, some users reported some issue with the Windows 11 and importing this VM. But anyways, like if Anyways, so available for VMware Workstation, officially supported. You can also try it on VirtualBox. I'm not sure how it would work. I have not tested it personally. Ever since I tested initially, but yeah. Anyways, so our some of the future roadmaps include support for Apple Silicon architecture. So essentially, this is available for x64 right now. So some of the users who have moved to the Apple Silicon architecture M1, M2 chip, so they are not able to access it. So we are working on creating a VM or which will be supported for the Silicon architecture. And right now, some of the things we have is the tools they are statically built. So we are planning to include these tools via app, so you can simply update it using the CLI just like you normally do on a Linux system. And we are also looking forward to include more of the tools. So if you have some tool idea, you feel free to submit it to us. And this is the link. So I'll quickly. I hope this screen is visible, right? So I'll quickly show you this. So this is the RedCloud. This is the official repository of the RedCloud. And if you want to submit any feedback or something, so you can either mail us at this address, or the best way for this is you can create an create an issue here, and then we can discuss or figure out if some tools or some recommendation is there which we want to include in our RedCloud. Anyways, moving back. Now let's look into, so for till now we have talked about the how we can access the cloud and what is RedCloud OS. Now let's look into some of the attacks or some of the kill chains which is available or which is more suitable for the cloud. So this is one of the cloud attack life cycles, or you can call it cloud chain. So initially, our assessment begins when we are doing the recon of the cloud services, which are publicly available, or even if we have access to the organization, we can do the recon internally with the use of keys and other credentials. So once we do the recon, we often find some misconfigurations. And here is a thing: there are very less vulnerabilities in terms of cloud, because most of the issues we see with the cloud, they're often misconfiguration, and these misconfigurations are what makes cloud attack surface very lucrative as well as very dangerous, because some of these misconfigurations, they actually exist when you're provisioning resources or when you're using default stuff, which we will also be seeing in a couple slides later. So understand this very carefully. Cloud attacks, they are mostly targeting the misconfigurations, which is happening while provisioning or managing these services. So, anyways, so once we do the recon, once we figure out some of the juicy details, we can then move to the initial compromise. And in initial compromise, we just grab access to some of the resources, or we extract some of the higher or some of the other services. We access some of these services, and once we establish the initial access, we can simply move on to the establishing the persistence. So just to give an example, let's say we got AWS credentials. We did some recon, we figure out, okay, so I have access to assume role thing, and I can assume some of the roles. So then I can simply assume role of a higher privilege account, and from there I can establish persistence, because that is a higher account. And if that IAM role, let's say, has access to creating IAM policies or other IAM roles, so I can also create those roles, and that will be the persistence and escalating privileges. So these two are often combined in these terms. So again, once we did the recon, once we compromised the initial service, and once we establish the persistence, then we can move to escalate privilege. And once we get there, so we can again do the internal enumeration. We can find some credentials. We can move laterally to other services or other clouds or other accounts in case of multi-cloud architecture, which is actually very common in modern organizations. So these days, organizations, they actually do not rely on one single cloud. They actually do a bit of hybrid combination. So some of the infra is actually on the local on-premises systems, and some infra is distributed across multiple cloud providers like AWS, Azure, IBM, GCP, Google, so Oracle, Alibaba, whatever. So this is distributed system. So from on-premise, we can move to the cloud. From cloud, we can also move to the on-premises depending upon the configurations of the particular organization. But anyways, so once we did this, once we got till here, once we got till lateral movement, then let's say we did the initial recon of AWS, we compromised some of the services, we figure out some ways to escalate privileges, and we escalated. From there, we are moving laterally. Let's say there is a connector between AWS and Azure. So from there, we can move to Azure, because if there is a connection, there is some sort of credential involved. Even if we are connecting two clouds, or even if we are connecting two services, there is some sort of credential that is involved between these services. So what we have to do is we simply have to exploit those connectors. We have to simply extract the credentials, and then we can move to the different cloud. And from there, the same cycle continues. Again, we go to this recon and this. Again, we go to this recon and we do. Okay, here is Elizabeth. Okay, yeah. So again, we go to this, we did lateral movement, and from there we move to another cloud. Then we establish persistence, this. Then we did the data exfil, whatever is our end goal. So whenever we are doing red team operations, there is a certain end goal. It could be accessing some secrets stored in some isolated location, or it could be extracting some I like the intellectual properties or something. Like it depends on the nature of assessment as well as the client. So once we did the data exfiltration, we can establish the impact, and then our operation is complete. So this is a kind of a cyber kill chain, which is mostly followed by the red teams. And again, it relies mostly on the misconfigurations. Now, moving on, let's see the AWS hierarchy. So in AWS, we can create actually if we have multiple accounts, like because it's actually a good practice to have multiple accounts for different tasks, and we can group them together with a hierarchy. So in AWS, we have the concept of organization, and inside the organization, we have the concept of different objects such as one account, then second account, then third account. Understand it this way. Let's say if we are talking about the active directory, so in active directory we can have multiple forests, right? So this is the similar kind of thing. We have one organization that is the master, which is managing all the other accounts, and inside those accounts we can provision multiple resources, multiple different stuff, whatever we are provisioning and managing. And this is how AWS's hierarchy looks like. Now, let's look into the architecture of the AWS. So, in AWS, we have two different spaces, which first is the cloud space, and this cloud space is the service that is being offered by the AWS. Inside this cloud space, we have different other components. So, first is the web portal GUI through which we access. Then there comes the AWS services, which are in the control plane. So, these services are what we provide, like the resources we provision, they are provisioned inside these services. And inside these services we have the other data plane, which is the actual resources we provision. And these resources can be the compute or the storage or database or serverless, whatever, whatnot. Now, this was the space that is being managed and controlled by the AWS. And then comes the end user. So in end user, we are the end user. Obviously, we are using some sort of stuff or some sort of software to interact with these services, these AWS services. So first method is using the web GUI. So in the web GUI, if you look into this Firefox icon, so we have two types of credentials. First is the IAM username and password, and second is SSO, that is single sign-on. Also, on a separate note, if you want to learn more about the IAM, or if you're not familiar with the IAM, we actually did a webinar a few weeks or a couple weeks back. You can look into that webinar. That webinar was targeted towards the IAM, particularly in the AWS. So yeah, anyways, moving on. And if we want to interact with these services through programmatically, or we do not want to use the web browser, we have the option of the either CLI or the SDKs. And these CLIs and SDKs can be configured with the two type of keys. First is the long-term key. So this is a key ID and a secret. and it is valid for the long term until it is revoked, or until, I think recently AWS has introduced some stuff. So if your key is inactive for a certain period of time, so it is disabled by the AWS. I mean, they actually did disabled one of my keys when I was away for a while. So, and anyways, there is another keys, that is the short-term keys. So these short-term keys are very short-lived tokens. So they can be valid for 60 minutes or 2 hours or 8 hours. It can be configured that way. And these include a token. So we have actually talked about the token before in few slides back. So this is how we can configure the short-term keys with the help of the access key, secret, and the token. Now moving on to Azure. So Azure actually takes a bit different approach. So in Azure, we have our identity provider, which is Entra ID, previously known as Azure Active Directory. So Entra ID is used to manage the resources, or in terms of resources, what I mean by resources is the identity resources. It could be user accounts or other credentials. So these are managed by the Entra ID now. On from this Entra ID, we have two different type of offerings by the Microsoft. That is resource manager, through which we provision the Azure resources, and then comes the Office 365, or as they named it recently, Microsoft 365, which is our Office, Outlook, and SharePoint and whatnot. So these comes under this Office 365, which is a SaaS offering, software as a service, and previously the Azure portal. It is a combination of both because we can deploy actually multiple things there depending upon our use case. Now let's look into the Azure hierarchy a bit more. It will help us clear some of the things which are actually most commonly misconfigured. So look here, this is the Azure cloud. Inside Azure cloud, we have different objects. So first is the Azure AD or Entra ID, which is managing our identities. So here we can manage our user app devices, our roles, whatever roles we are assigning. So in uh, Android, we have different roles like support administrator or security administrator or app administrator. Like there are different roles we can configure and different users we can provision, which is managed by the Android. After this comes the main Azure cloud. This Azure Resource Manager is what is used to provision resources in the Azure, and it has different subcomponents, like it has compute, storage, networking, access management, and whatnot, and everything that we provision inside the Azure cloud. It is managed by this Azure Resource Manager, and then comes their SaaS offering, that is Microsoft 365, which is just our Office suite with some additional tools like again Outlook, Docs, Teams, and whatnot. It comes under this particular offering, that is their Microsoft 365. Now coming back to this, so again this is pretty much the very same thing that we saw in the case of AWS. So again we have the Azure portal, which we can access through our web browser, and we can use our username and password, which was provisioned by the Entra ID. We can use it to interact with the Azure portal using our web browser, and it actually lies in the Azure plane. Then comes the APIs or control plane, which was also present in the AWS. So let's go back to AWS. Yeah. So this Azure services, this is the same as this Azure APIs, and we can use two ways to interact with it. First is Azure CLI or their PowerShell modules, and then the API client. So if we opt in some sort of keys, so we can see these keys. We have client secrets, username, password, and access token. So we can use these keys with one of these, and we can interact with the Azure APIs or Azure control plane. And control plane is what we use to provision the services in the data plane. Moving on. Now simplifying the Azure architecture a bit. So this is the Azure Active Directory or the Entra ID, which is at the top of it. And inside this comes the management groups. These management groups are responsible for provisioning different subscriptions, and subscription are how we classify. So think of the subscription as the separate AWS account. Think of this management group as your root account or your organization master account in AWS, and consider this subscription in Azure as your account in AWS. Inside this subscription, we can create different resource groups, and these resource groups can be divided by the use cases or divided by the regions. Whatever, in, let's say if you want to provision different resources in different regions, let's say we have some apps, and let's say in we are deploying in US and EU as well. So in EU we have some restrictions on data collection and whatnot, so we can configure another separate resource group in the EU, which will be specifically targeted towards that region, and data will be stored in the EU region itself. So this can be like this, and inside these resource groups, we provision different resources. Again, the resources can be anything. It could be a VM, it could be a database, it could be um, functions or whatever, like anything we can configure inside the resources groups, and that will be the resources which we are provisioning and managing. Then comes the hierarchy of the Google GCP. So again, in GCP, we have a different concept as compared to AWS and similar to Azure. So we have our cloud identity through which we manage our authentication and user information, and it relates to GCP, which is the cloud platform where we are provisioning different services and where we are managing different resources, configuring and whatnot. And then comes their SaaS offering, which is the Google Workspace, which is Gmail, Google Drive, Meet, and Docs and whatnot. So these actually come under this particular offering, that is the Workspace, and the Google Cloud resources which we provision comes inside this GCP, their cloud platform. Now, this is the GCP architecture. It is pretty much similar to what we saw with the AWS and Azure. And give me a just please give me 1 minute. Let me have some water. Now, again here we have the web client, and we are using our username and password, which could be Gmail, G Suite, or Cloud Identities, and we can use it to interact with the GCP portal and simply use it through a web browser. Then if you want to access these programmatically or with the CLI, so we have different set of credentials. We can have the API keys, can have the access tokens, we can have different username passwords, and we can even have the service account JSON files. So these are the different credentials we can use to interact with the APIs. And this API, this is again the same thing as this control plane, and the same thing as this control plane in the AWS services. Then through these two methods, this web client or this CLI based or SDK based methods, we actually access these Google Cloud services, which can again be anything ranging from compute to serverless to machine learning, AI, chatbot, whatever. Okay, before moving on to the misconfigurations, if there are any questions, let me see. Can you talk a little bit slower? Yeah, sure. I'll try to talk a little bit slower. Is it Redcraft Infra tool? No, Redcraft is actually not installed right now because RedCloud was actually released approximately 1 year back, and Redcraft is something. Red Infra is something we have released very recently, so it is not available in the present version. But yeah, definitely it will be available with the next versions of the RedCloud which we will be releasing. Okay, going back to the slides. So now talking about the cloud misconfiguration. So we will be actually touching upon three most commonly used services of the cloud. First of which is the compute. Compute is where we are provisioning a VM and we are running some resources and some software on top of it. So one of the most um, kind of um, thing is it is publicly available. So these resources, these instances, they are available publicly over the public internet. And the disadvantage of this is when we are configuring these resources, these compute resources, we often take these snapshots or we often have our customized images. So these images can be considered as just if you're downloading an ISO from, let's say, Microsoft or Ubuntu or Debian. So it is an ISO, it is a customized version of an operating system. So in most enterprise scenarios, the organizations, they actually create their own operating system images. through which they provision different resources. And so, to give an example, let's say there is an organization which has a specific custom developed web server software, and they also, let's say, they tweaked it. They also tweak some of the OS kernels stuff to make it more secure. So it will be hectic to deploy it on a publicly available image. So let's say they created their own image, their own OS on top, not OS but OS image. And just to clarify a bit, so OS is the operating system, and OS image is an image which we build on top of an OS. So we can also consider RedCloud as an OS image because it's actually built on top of another OS. So again, these enterprises, they often configure their own images, and these images are often exposed publicly. So if I can find some of these images, I can find some of the secrets or some of the internal configurations or some of the source code. And actually, there was a very good talk this year at DEF CON. Uh, I for, I mean, I know the name of the guy. I just am unable to pronunciate it, and I actually want. But there was a very good talk about the cloud AMIs and the secrets that are lurking in it. So, in that talk, that guy and one of the co-speakers, they actually explored some of the AWS AMIs which are available. And AMIs is just a OS image, Amazon machine image. So they actually analyzed and scanned these AMIs, and they found some of the secrets that were lurking. And this was all available in the public. So this is one of the risk of running something that is publicly available, because if often we misconfigure these and often we do not protect it, and it is available to the public, they can dig into it, figure out some of the things. So two things are there. First is the public snapshots of the VM, and the snapshot is just like what we take on VirtualBox or VMware. These snapshots we take of a VM frozen in a particular instance of time. Now that is the first point. Second point is open ports. So open ports is something like if we are configuring an instance, and let's say we have something, um, let's say we configured a web server. We configured three services. First is the web server, and second is the SSH to log into that server. Now, the web server ports, port 80 and 443, they are to be publicly available because you want the people to access your web server. However, the SSH port 22 or whatever port you are configuring it should be protected to prevent the attempts of login or prevent the attempts of some of the people trying to enumerate or figure out what service is running. So it should be, or not should, it must be blocked, or it should be locked to a particular range of IPs. However, this is not the case with many of the services, compute services we see out there. They are mostly available to anyone because this is something we have to configure. This is by default. If you are provisioning it, it will be accessible to anyone on the internet who has access to this particular IP. And believe me when I say this, I actually run some of the internet research, and personally, I have figured out that if you're opening any of the ports in any of the machines in any of the cloud, you will get your first scan request within few minutes. And there is not only single organization running these scans. There are literally hundreds of organizations which are actually scanning the public IPs. And right now, with the evolution of software technologies and introduction of, like, not introduction but the presence of languages like Rust or other languages, it is very fast. Like this recon, this scanning process is actually has actually become very fast to scan all of these particular IPs and ports. So I mean, try it. It would be fun. Just run one of the VMs on any of the cloud. Just open some of the ports and capture your data. So best way for this would be just simply open any of the ports on, let's say, provision of VM on any of the Azure or AWS or GCP. Just run the simple Python server, Python 3 tag m http dot server. Run it on any of the port. You will see the first request coming within few minutes. Anyways, moving on to this. Now, in terms of the services, like right now, the software architecture is something like this. We have a front end service, we have a back end service, and these front end and back end they interact with each other to provide the different services to both of them. So front end could be fetching some data from the back end, or back end should be putting some data to front end to render to the user. Now, ideally, the front end should be publicly available while the back end should be protected. So it could be configured in such a way that we are putting this front end in a public subnet, and we are putting the back end in the private subnet, and we can make a connection between these two. However, this is not the case in most of the scenarios. So most of these are publicly available, and they actually use the public IPs to interact with each other, which is not a very good practice, but it is still um, very much happens. Now comes the vulnerabilities which lead to uh, one of these two, that is SSRF and RC. So how, when we provision these resources, be it the cloud or be it something, so be it the compute resources or database resources or whatnot, so they actually interact with the cloud providers using, and let's go back a bit. So this APIs, these control plane, so these services, we can see like there is a connection between these two services. So they actually interact with these services, and how they interact with these is through the internal metadata endpoints. So it could be metadata.google, or in case of AWS 169.254, 169.254 for the metadata services, and this is how they interact with the control plane and fetch some data, send some data, or just interact exchange some data. Now, if we can get SSRF or RC on these instances, we can actually interact with the control plane. And from there, we can actually extract some of the tokens or some of the keys or some of the secrets. And we'll just see this in a bit. So, um, anyways, and again, the fifth thing is overly permissive IAM policies. So, by default, when we're writing IAM policies or IAM rules, they're overly permissive. They give you too much permission than you really need to run. I mean, this is how it is configured. It should always be fine tuned. But anyways, moving on to the identity or IAM services. So these are some of the things that actually lead to these misconfigurations, because of misconfigured IAM is one of the uh, most commonly used attack vectors in terms of cloud. So first is the use of root account for resource provisioning. So never use your root account, just create some other account. And this is specifically true in the case of the AWS, because in AWS, unless we create a IAM user and assign some policies, the root user is pretty much capable of doing everything. And I mean, it is something that, well, it has become less and less common in these days, but still it happens, mostly in case of the developers. Anyways, moving on, the another thing is lack of MFA. So if we are using different credentials, let's say we extracted some credentials from, let's say, a browser session of a client's employee. Now if there is no MFA configured, we can simply use those credentials to interact with the cloud providers. Third is the use of wildcard, which is something that is pretty much the most dangerous thing out of all of this, because if we are assigning wildcard, it means anything within that scope. So if let's say we are assigning wildcard in the principal, so in the principal AWS we have a concept of assume role, and in assume role we have to define principal, which principal we want to assume the role of. And if we are assigning wildcard to it, it is pretty much dangerous, because I can assume the role of the any of the users, higher privileges users, and that is something that is going to bite me at a later point. Then comes the topic of assigning overly permissive rules and policies, which is available by default. So if we are assigning default rules or default policies, so they are pretty much overly permissive. And like the last point is the insufficient logging and monitoring, because if anyone is having some access to our cloud, if we are not monitoring the proper access, let's say if we have an employee which is based in India, and he's only logging from India in a particular time, let's say 10 a.m. to 5 p.m. However, if we get a login from, let's say, I don't know, Greenland or Iceland somewhere, so if we are not able to monitor this thing, we are pretty much doomed, because that is an anomaly. And if we do not have proper logging and monitoring setup for these sort of things, so I mean the credentials compromise could never be detected, even unless the attacker did something that is very obvious. Anyways, moving forward, this is the third thing, that is storage. Storage is your Azure blob storages, or Google Cloud buckets, or AWS EC S3 buckets. So one of the most common thing is the anonymous access is available to the bucket objects, and they are publicly available. So if the anonymous access is available, I can simply pretty much get access to the bucket. I can enumerate the contents. I can figure out if some other things is hidden. And there has been instances where some of the buckets were made public with credentials such as the Terraform state files. And state files, they contain a lot of information that is very crucial for the organization, like some of the secrets and keys, they're also available in the state files. So these things have been discovered, and I mean it's been pretty revolutionary. So since then, most of the providers, they have actually disabled this thing, even AWS. So if you are provisioning an S3 bucket, so public access is disabled by default unless you enable it. But it was a thing in the past. Still, this is pretty much very common. And another thing is, with this is overly permissive IAM policies. So um, if we configure IAM policies, and if we have some other misconfigurations, like if we are allowing anyone to assume the role of the owner, so it can also be done through the cross account. So let's say, let's consider an example. Let's say I have a AWS account, and I configured a S3 bucket, and in the policies I allowed anyone to assume the role, anyone across AWS. Now, an attacker with the other account, they can actually assume the role of the owner of the bucket. They can modify the content, they can delete the content, and it was actually, and something like this actually happened few years back. So one of the organization, they had some buckets, and someone exploiting this particular vulnerability, they actually managed to delete everything from those buckets. I mean, everything was lost for the organization. They had a couple buckets, and the attackers, they leveraged it and deleted everything. So these are three of the most common misconfigured cloud services which we have seen. And now let's look into the demo. And I'll be running this, I'll be cutting it very short, because right now we do not have much time. What's bucket is used for? Okay, so there is one question, what's bucket is used for. So bucket is actually used for storing some of the objects, some of the data. So let's take an example. So if you're using Windows, you must have OneDrive, right? You're storing something in OneDrive. In Google, we have the concept of Google Drive, where we're storing some of the things. So the same is true for the buckets. So in buckets, we are storing objects. These objects can be anything. These can be a data file, text file. This can be a MP4, like whatever we are storing. So it is actually very scalable, and it is used by a lot of people. Okay, now I'm gonna share the screen. Please let me know if screen is visible. Okay, thanks. So this is the RedCloud OS. If you look into this, we have different section for different tools. Please give me 1 minute. Yeah, okay. So if you look into these tool section categories, we have four different tools here, four different categories here. First is for our AWS tools. And these AWS tools, like not AWS, but every of these tools, they're actually divided across three of the categories, three of the attack phases. First is enumeration, second is exploitation, and third is post exploitation. Again, Azure is of the same thing, GCP is also of the same thing, and multi-cloud tools. So these tools are available for multiple cloud services, and they also are categorized in the three of these tools. So if we open any of these tools, let's say we are opening this Cloud King, so we can simply click on it. It will be opened. This tool. Also, we have a PowerShell here. So if you want to interact with the Azure, so the best way to use Azure is using the PowerShell. So we also have the PowerShell here, which we can use to interact with the PowerShell services. And this is how this Red Cloud tools work. You can also check more details um, on the Red Cloud GitHub. So on the users and how you can use it. So since we are very short on time, I won't be doing a demo, but I'll show you something real quick. Please confirm if screen is visible. Okay, thanks. Okay, so we actually have a platform that is called Infinity Learning. The URL is this. I'll paste it in the chat. Just give me 1 minute. And let me also paste the link for the Red Cloud. So I have pasted the link for both the Red Cloud as well as the Infinity. So in Infinity, we are actually running multiple scenarios, and we have the cloud section, we have the DevOps, and we have the Kubernetes section. So these two are upcoming. One of the DevOps is pushed, and multiple challenges for the offensive and defensive in the cloud is available. So we can see something like this. So if you see, there are multiple challenges that are available, and these challenges, they are actually based on the real world scenarios that we have observed. So you just what I'll recommend is get the Red Cloud, familiarize yourself with these different tactics that we are running, and it is as simple as that. Simply, you have to simply open any of these challenges. Let's say we open this upskill cloud, then open either offensive or defensive. We are in offensive. Open any of these. This is, and there are filters available. So let's say I want to do this Azure IAM. Now I simply have to start the lab. Once I start the lab, I'll have some of the credentials that are available that are used for accessing this. Then I can read through this and I can perform the attacks and I can submit whatever the flag is. Also, we have the solutions here. So if you want to look into the solution, if you are stuck and unable to figure out some of the things, you can use it to refer in case of if you are stuck or doing something. So, anyways, this is for this, and the same is true for the offensive के साथ, like same is true for the defensive as well. And in the defensive, we also have multiple challenges across multiple categories, and which are also representing the actual real world attack breach scenarios which we have. So if you check this, there is something like this. If you click on start lab, you are getting some of the credentials for our elastic instance, and from there you can simply um, interact with the elastic and figure out some of the things. So yeah, so this is all for this. And yeah, so I'll just quickly take the questions and just finish this. So background noise is distracting. Yeah, I mean, yes. Which technique used by RedCloud OS to attack the AWS cloud? So it is more about the enumeration and recon phase. So whatever we discover, so let's say if we discover some of the keys, right? So from these okay, let's do a quick demo actually. Please confirm if screen is visible. Yeah, okay. So let's do a real quick demo. Let's see this. So we got this AWS access key, secret key, and the tokens, right? Now we can use the Red Cloud. Okay, I think you are only seeing the Red Cloud. Okay, screen. Just a sec. Okay, so this is one of the challenges we have. This AWS Compute one. So here we have a vulnerable portal, and we are using SSRF to extract some of the tokens. So you can see like we are using this internal metadata endpoint, and we are querying this endpoint with this particular role, and this is giving us the tokens. So once we get the token, uh, you can read the write up because we will be ending this. So from write up we got this. We can simply export this, these tokens, these things, and then we can call this. So let's mm, okay, let's do this. Okay, I'm gonna share quickly. I'm gonna share the screen of the Red Cloud. I'll simply copy paste the credits from there, and we will simply run one command and see how we can actually do this sort of thing. Okay, so I actually already have one key configured. Okay, actually this is a short-lived token, so I have to take a different approach. So we configure the tokens and we query this particular account. So you can see, okay, this is the account, this is the user ID, and this is the stuff. So this is actually how the Red Cloud works. So we have different tools for different purposes. And it depends upon how you're using these tools and what techniques or what particular things you are covering. Real world scenario, can you use share the coupon code when I want to download the VMI, unzip the VM? Yes. So yeah, that is the pretty much just thing. So you just click on the link on the chat or GitHub. Then you simply download the VM from our drive, and from there simply extract it and import it into your VM. The recommended hypervisor is VMware Workstation, but whatever works for you. Can't you guys buy a better mic? It's so irritating. Yeah, sorry about that. Hmm, can I access Infinity Learning for free? Yes, the Infinity Learning is actually available for free. So um, just to register it, go to infinity.cyberwarfare.live, and from there simply you can um, sign in with your Gmail account and get the access to the whatever challenges we have out there. In the real world assessment you can't get any crits. Yeah, I mean, see, the most efficient way to conduct a red team operation or even a pen test is if you are going through an assume bridge scenario, because it actually takes away some of the burden of configuring, so like performing some of the initial stage stuff. But yeah, I mean, um, okay, yeah. So it is actually a very good practice for the organizations to share the um, credentials for the assumed scenario. It actually saves time. But yeah, I mean, you can't. Some people like they do not give. But yeah, I mean, you can always ask for the credential. It is most efficient that way, and it is also most easy on the time as well. The time restraints we have for the operations. Is MCRT we can do without any basic knowledge? Yes. MCRT is for the beginners only. So everything is taught to you from the very beginning. So yeah, you can do it with the uh, just a basic knowledge. Basic knowledge as in if you know networking, if you know the CLI, that is pretty much the extent of it. Is there job opportunity in cloud security? I mean, you can search for it. I'm not very familiar with the cloud of like opportunities for beginners right now, but yeah, definitely they're out there. They're rare, but still out there. Where is the coupon code? So yeah, now going back to that, this is the coupon code. I hope this screen is visible. You guys can see this screen, right? So this is the coupon code on Cloud 90. Please use it to get the 90% off. And yeah, so this is pretty much the end of it. And we are over 5 minutes, so we will be wrapping it up. So just taking one last question. What is it with course materials, free book on intro? Oh, this course material is actually available in the Red Cloud. So it is kind of an introduction. You're just giving an introduction of the cloud, how multi-cloud red team works. So this is just a PDF that is available. It is also available on our GitHub in the Red Cloud page. So yeah, that's the extent of it. So thanks folks, thanks for joining. Have a great weekend.